In this video, I'm first going to show you that there are two unique solutions. If you have a degree 2 or a quadratic equation, it is possible to have up to two unique solutions for the equation. I'll then go step back and show you the technique for solving with factoring. Lastly, I'll review the process and talk about why it works the way it does. First and foremost, I am declaring that there are two solutions. The two solutions to this equation are x equals -5 and x equals 2. What I'm going to do now is show you that these are the true solutions. Again, what I'm looking for, the solutions to this equation are the values that I can plug in for all instances of my variable x in this case to make the equation true. Specifically, does this expression turn into 0 when I plug in a -5 and a 2? First with -5, I'm plugging -5 in for the x here and the x here. So I get -5 squared and 3 times -5. When I work out the left side of this equation, I get -5 squared is 25 minus 15 minus 10. When I do the operations here, 25 minus 15 is 10. 10 minus 10 is 0. That means -5 absolutely is a solution. 2, I've done the same thing. I plugged it in for both instances of a variable x. Here I get 2 squared is 4, plus 6 is 10, minus 10 is 0, giving me 0 equals 0, and proving these are both solutions to this quadratic equation. Now we know there are two unique solutions, but let's talk about how to actually go about finding them. First and foremost, with degree 2 and higher polynomial equations, we can't isolate x in the same way we had with linear. For instance, if I had a linear equation of 2x plus 3 equals 10, I can simply isolate the x. Here what I would do is subtract 3 from both sides and then divide by 2, undoing the order of operations to isolate the x. In this case right here, with polynomial equations, we'll have terms of different degrees, meaning we can't combine these x's together, and there's no way to isolate the one x. If you're asking, I'm going to solve for x, well, which one of these terms are you going to attack? So we have other techniques, the first of which, again, we're going to talk about today, is the method of factoring. So here are the steps for solving by factoring. First, what we always need to do is set one side equal to 0. We do this to use the zero factor property, and again, I'll talk about that more at the end of the video. Once we've set one side equal to 0, we need to factor the non-zero side, or the interesting side to factor. Finally, once we have the one side factored, it's set equal to 0, we're then going to take each factor and set those to 0 and solve them. For our first example here, well, let's set up to work nicely. We have one side set equal to 0 right here. Now we need to factor the non-zero side. This is an important technique. You need to know how to factor quadratics of this type right here. As a quick reminder, to factor this, I'm looking for two numbers that multiply to be a -10 and add to be a +3. In this case, that's an x plus 5, or a +5, and a -2. +5 and -2 multiply to be -10, and they add together to be a +3. So I have factored the non-zero side. Last but not least, what I need to do now is set each factor to 0 and solve each of those. So here I've taken my x plus 5 and set it equal to 0. I'm simply going to solve this linear equation by now subtracting 5 from both sides to get x equals -5. And over here, I'm going to add 2 to both sides to isolate the x to get x equals 2. It's as straightforward as that. I've set each side equal to 0 and solved them. These are the two solutions that I've already justified earlier in the video. Let's now take a step back and wonder, why does this even work? Why is it important that we set this equal to 0, and how does factoring help us? We use the zero factor property to solve by factoring. The zero factor property is a pretty dang straightforward property of mathematics. It says if two numbers multiply together to be equal to 0, then one or both those numbers must be 0. That's the only way to get two values to be equal to 0 when multiplying. So again, the steps are, we first have to have this set equal to 0. The reasoning is we want to use the zero factor property, which is the product of things being multiplied together to equal to 0. Then what we need to do is write this expression in multiplied form or factored form. And we found that to be x plus 5 times x minus 2. And now the statement was, one of these at least needs to be equal to 0 for this multiplication to be equal to 0. To clarify that, what I'm going to do is plug in x equals -5 into the factored form. We've already plugged it into this form, but I'm going to plug it into the factored form and show you why it works as an answer in this form. When I plug in x equals -5 into this factor, I get a 0 from -5 plus 5. In this factor, I get a -7, though it wasn't really necessary for me to know what the second factor is. I know that 0 times anything is equal to 0, and therefore it's a solution to the equation. You can see, lastly, that if I plugged in a 2, or x equals 2 into this expression, it would make this factor equal to 0. And again, I could care less what this factor is going to do. Anything times 0 will give me an output of 0. And a full circle, that is why we make the factored form of this. When you look at the original expression, there's no real way to know that with the pluses and minuses out here, how to make this thing end up being 0. What we do is we'll write it in a multiplicative form or factored form, and then we look at each of these, attack each factor separately, making it 0, knowing that that will make the whole multiplication equal to 0.